So we're going to talk about, well, we're going to start talking about objects. So what I'm going to do here is I'm going to create our own class. For right now, I'm just going to get rid of everything in main. So underneath Hello World, I'm going to right-click on the package. I'm going to click New and click Class. We're going to define our own object. So for right now, we're going to call this guy a my object. Just for no good reason. Okay, so here's my object. Now, we're going to say that my objects can hold on to two pieces of information. Let's say they can hold on to a first name and a last name. Do that. So I'm going to say string fname, string lname. Then we need a constructor for my objects. Okay. Now, let me actually start this off even easier. We're going to do a constructor that takes no parameters. So this is the simplest form of an object. So we have an object called my object, so it's a class called my object. This guy, it keeps track of two pieces of information. And I have a constructor that does nothing. So actually I can leave this out. It'll give me one for me, so I could do this. Okay? Now, remember way back when we talked about there are two types of programming languages, loosely typed and strongly typed languages. Okay? And when we talked about types, we said there's two different kinds of types. There's primitive types and there's object types. Primitive types are types that are built into the language that can only hold a value. Object types can hold a value and potentially do more. Okay? They can potentially hold more than one value as well. Now we're creating our own object types. We've been using object types like string, like big integer, those things. Those are all object types that were already in the language that came with Java. But now we're writing our own. We're writing this thing called my object. And this guy knows how to hold two pieces of information, a first name and a last name. So I'm going to come out here to hello. And I'm going to say my object mo1 is equal to a new my object. And I'll say mo1 dot first name is equal to Mike. mo1 dot last name is equal to Littman. And then I'll say system.out.println mo1. What's going to print out? An address. This is an object. So it's going to print out crazy memory address. Why? Because I used my real estate agent. That guy gives me memory addresses. Right? Now, this object holds internally two pieces of information, a first name and a last name. I can go in and I can add another ability to this. So inside my object, I can add the ability void display. System.out.println first name concatenated with a space, concatenated with last name. Save that. And now I can come in here and I can say mo1 dot display. And it will print out the name. Like Littman. Does that make sense? So what I did is I built this object that can keep track of two pieces of information and then can display those pieces of information. So it can hold one or more values. This guy holds two values. And it can also potentially do more. Does that make sense? Objects were born out of something called structs in C, the C programming language. So the whole reason object-oriented languages were even born, at least a very, maybe saying the whole reason is unfair, but certainly a major reason why object-oriented languages were even born is because structs became so useful in older procedural languages like C. A struct allowed us to hold multiple pieces of information inside of a single variable. Kind of like what an array lets us do. You know, like with this last time we used arrays to hold the numerator and denominator of fractions, right? But the problem is that starts breaking down pretty quickly if we're holding on to a bunch of information, right? We had to remember that bucket 0 of our array was the numerator, and bucket 1 of our array was the denominator. We had to keep track of that in our head. Does that make sense? Well, with this, we can create our own fraction object that holds 2 pieces of information, a numerator and a denominator, and do things with them. Okay? But that's going to be your homework assignment, so I'm not going to actually solve that problem for you. But we see we can hold as much information as we want. Now, let's talk about constructors. Constructors always have the same name as the class. If you do not create a constructor, a no-argument constructor will be created for you so that syntax right there will work. So a no-argument constructor is a constructor that does nothing except make this syntax function correctly. It's a constructor that takes no parameters and does nothing. Okay, and we didn't have to write that. The second we decide we're going to write one, well, I don't even need to make it public. So let's say I want to write my own constructor for this object. Notice that the name of the object is my object and the name of the constructor is my object. Identical. Okay? Notice that constructors look a lot like methods with one exception. They do not have a return type. All constructors have, a constructor will never have a return type. Why? Because they always have the exact same return type, which is a memory address. Therefore, Java doesn't make you write it. That's how they work. Okay? So, we're going to create a constructor in here. And when we call upon it from hello.java, instead of setting fname and lname to Mike Littman after the fact, what I want to do is I want to build a my object, passing its constructor, my first name, and its constructor, my last name. I want to pass it those 2 pieces of information. I want to give the constructor the information it needs in order to successfully build this. Make sense? So, I need to write my constructor to work that way. So my constructor expects 2 strings to come in, first name and a last name. You can name them whatever you want, but I purposely named them the same as these guys up here to teach you a new concept. So what I want to do is I want to set this variable up here equal to whatever this guy was passed in, and this variable up here equal to whatever this guy passed in. So we use the assignment operator, so I would say fname is equal to fname, and lname is equal to lname. We have an issue here. When we resolve variables, they always resolve to their most local definition. That is, when I say fname here, fname will resolve to the value associated with its most local definition, which is this version of fname, not this version of fname. So I need to have a way inside of a constructor of differentiating between this local variable and this global variable. These global variables that are part of objects are known as fields. Okay, these guys are fields. It's an instance field. And the way I do this is with something called the this keyword. So inside the constructor, we're saying this.fname is equal to fname. fname boils down to this guy. This dot fname is this guy. Now, this keyword is very difficult to explain without using the word this a bunch of times. The way it works, what this keyword is, it is how an object refers to itself within itself. It's kind of like how we would say, my name is Mike. Does that make sense? I don't say Mike's name is Mike. I say my name is Mike. It's my is how I refer to myself. The Java version of that would be this name is Mike. That make sense? Yeah. Okay, so that's what this keyword is. It is how an instance of an object refers to itself within itself. Now, the quick and easy way of doing this is instead of taking in string first fname and lname, you would take in string fn and string ln, something like that, and then you wouldn't need to do this whole this dot crap. Because they're all going to resolve to their most local definition. Fn resolves to its most local definition. Fname resolves to its most local definition. Why didn't I do this? Why did I do it that other way? Why is the other way better than this way? Nope. There's a valid reason why it's better. Most inexperienced Java programmers would take this cop-out. There's a very good reason why this cop-out isn't acceptable.
Help you show us the distinction between
I'm going to go into a different language. And I'm going to create an object, the equivalent of this object in a different language. Okay? So what I'm going to do is we'll go in and let's do this in Objective-C. Objective-C is a good language for doing this. So I'll just do it inside this project here for right now. So I'm going to right click. I'm going to create a new file. Objective-C class. This guy's going to be an NS object. We're going to call this guy my object, just like we did before. All right. Now, I want to be in the dot. That's fine. So, what we're going to do here is I'm going to write a constructor. Well, for starters, Objective-C splits these guys between two files. We have an interface that's in the .h file. So this is where I'll define my two fields, fname and lname. Okay? So now I'll go over to the .m where I'm implementing this. Now I'm going to write my constructor. In Objective-C, constructors do not have to have the same name as the name of the class. And the reason I like using Objective-C to show this is because, like a few minutes ago, I said that in Java, constructors have to have the same name and never have a return type. Why don't they have a return type? Because the return type is always a memory address. Java hides a lot of stuff from us because it wouldn't make sense for it to be anything else. Now, that's convenient after you understand the concepts. But early on, they're hiding things from you that are important to understand. So one of the reasons I like looking at Objective-C is they don't hide those things from you. And you'll see this by example. So I'm going to write a constructor for this. And it's going to return an identifier, memory address. Okay, return a memory address. Whereas constructors in Java don't return anything. Well, they do. We just don't say that they return anything. And I'm just going to call this guy init. Most constructors in Objective-C start with the word init. Okay? You can call it whatever you want. You can say build a my object with first name and a string pointer fn and L name and a string pointer ln. So this would be the equivalent constructor in Objective-C. Build a my object with fname, this guy. So this is our first parameter, and this is our second parameter. Notice I named the parameters fn and ln here. I'm telling you that this is reasonable. Yet in Java, this is not reasonable. Let me copy this code here, just so we can compare apples to apples, so to speak. So here's the Java constructor, and here's the equivalent Objective-C constructor. Why am I saying that taking in a parameter fn and ln here is acceptable, but taking in a parameter fn and ln here is not? Okay, what does the address have to do with anything? Well, here, self in Objective-C, this guy, that's equivalent to this. That's Objective-C's version of this, the word self. Now, notice that this guy up here doesn't have a line that defines this and doesn't ultimately return this. Even though I promise you that Java's constructor is in fact giving a value to the this keyword, and then also at the very end is returning the this keyword. It's returning a pointer to himself. Objective-C shows it. So in Objective-C, the very first thing we do in any constructor, we give a value to self, value to this. What's the very last thing we do? We return a pointer to ourselves. Java's doing the same thing, they're just not showing it to us. Okay? So, very similar argument, but that's not what we're talking about right now. What we're talking about right now is why is it acceptable for this particular method in Objective-C to take in parameters named fn and ln, where it's not acceptable for that to work that way in Java. When I say not acceptable, I'm saying it's not up to my standards. You could do it, but it's a cop-out. Here's the reason. Notice, go ahead. Huh? No, not optimal code. I would say I'm looking for code that other people can use. Self-documenting code. If you look at this constructor in Objective-C, it reads like a sentence. Objective-C is a much more descriptive language. So this method, if you will, this constructor, is build a my object with fname, here's a parameter, and lname, here's a parameter. Is it pretty clear to us that this parameter is our first name? You would have spelled it out a little more? With first name and last name. Pretty clear that this guy is a first name?
Oh, yeah.
Pretty clear this guy is a last name? Why? Because I was able to describe what I'm expecting beforehand in Objective-C. Java, we don't have that luxury. Java isn't descriptive like that. It's shorter. A lot of people, when they first start writing Objective-C, they're like, okay, this is stupid. Way too much code. After they've been writing Objective-C for a couple of months, they actually prefer it. And it's hard to go back and write stuff in Java. Java is not nearly as expressive. So when we say build a my object, all we really know for sure is this guy needs 2 strings to work. We don't necessarily know what fn and what ln are. We might be able to make a pretty good guess, but to be honest, my object doesn't really scream takes a first name and last name, does it? You know, maybe a my address object might, something like that, but a my object doesn't. So really, we need to be much more descriptive with our variable names in Java. Good.
For the Java, really, wouldn't we be able to pass in any 2 streams, and it really won't have to be the first name and the last name? But with Objective-C, you would always have to pass in a first name.
No, I mean this guy requires 2 strings. I can pass in whatever strings I want, but this method is doing a much better job of telling me what kind of strings it expects.
Okay, so it don't have to be.
No, a string's a string. Yeah,
Okay.
I mean, an NS string is the same thing as a Java string. So a string is a string is a string. This guy just happens to be strongly implying, I would like you to give me a first name, and then I want you to give me a last name.
Okay.
Where this guy, now he's implying that much clearer, right? But when it was just fn and ln, it wasn't that clear.
Gotcha.
Does that make sense?
Okay,
So here's the way I had it before.
so you don't absolutely have to use that Objective-C method for only first name, last name. You can use it for, city, state, or whatever.
Well, yeah, I
You know.
suppose you could, but then I mean, then it would be even worse code. Then it's just a lying code. Like, look, give me your first name, give me your last name, but I'm going to treat it as an address and a zip code. That's what I really expected to give me, even though I told you something completely different.
But yeah, I was just trying to make sure I had it straight in my head that even we can reuse that same method for other reasons within the same.
Well, you could, except this method, more than likely, if this method is telling you to pass in a first name and pass in a last name,
Right.
the stuff inside of it is probably doing things with first and last names. So
Well, yeah. I
you
get
can
that.
pass it any 2 strings in the world. You can just randomly bang on the keyboard and pass it in there. And that person's going to have an unpronounceable first name and an unpronounceable last name. But the point is, you could do it. Okay, but bottom line is in Objective-C, naming conventions say that we should have very descriptive methods, very descriptive constructors. Java, we can only be descriptive through our variable names. So using shorthand variable names just so they don't match our fields is a cop-out, is what I'm getting at. So, go ahead.
Yeah, you want to like what I understand. I said you want to fill out the whole environment when you develop or when you create or when you write a code should be non and maintainable. To make your code everybody can read it, clear it,
Self-documenting.
maintainable.
Okay, your code should be self-documenting.
That's what we
Yep. Well, not just what I'm looking for; it's what anybody should be looking for. I mean, otherwise, so for those of you who go and get your answers to your assignments off of Google, which some of you do, I can tell because they're the ones that use a whole bunch of methods that we haven't talked about in class. Those are the ones. You can't figure out what code means. unless they've made it relatively documented, using variable names that make sense and things like that, right? I mean, I've been looking at code for a long time. I could probably reverse engineer something. I can look at it and say, okay, well, what is this guy probably? Even just take the, the Euclidean algorithm we looked at tonight. We had an A, a B, and a T, right? Well, those aren't descriptive at all, right? They're just random variables. We kind of had to walk through it to figure out what the thing was even doing. Well, that would be the same thing here if you start doing cop-outs with your variable names. Then you start turning into that where you just have a bunch of undescriptive variable names and hope whoever's using your code, whoever might be using it in the future, knows what you actually want them to pass you. So the reality is we would want to have very clearly defined variables. And then for our constructor, take in clearly defined inputs. And even though, I mean, the idea is that, well, we named our variable internally first underscore name, and we also took a variable called first underscore name. Well, why'd you call them the same thing? Well, you know what? That is the best way to describe that you want a first name. This is the best way of describing I have a first name. This is the best way of describing I want a first name. So the correct way of doing it is to name them the same thing. And then we have to use the this keyword saying I want to set my first name equal to the first name that was passed in. I want to set my last name equal to the last name that was passed in. And if you notice something that's kind of also nice about this with Eclipse, if you say this dot, it gives you a list of all the things that are in there. So I didn't have to worry about spelling last name right. You just select it. Make sense? So that's the advantage. So first of all, you get a little bit of a shortcut by being able to say this dot, and it goes ahead and gives you the rest. But you also have code here that is very clear. Even though Java is a less expressive language than Objective-C, which isn't better or worse. It just is what it is. So as a programmer, you have to take that into consideration. As a programmer, we have to come up with more inventive variable names in Java than we do in Objective-C, because Objective-C lets us write sentences as part of our method names. It's just a descriptive language. It's the nature of the language. So, in any case, this would be a nice way of writing this. I would say an acceptable way of writing this. That make sense? All right. And then I have my display method, and display method is going to display this, whoa, hello, this dot name, and this dot last name. That make sense?
It's displaying the first.
This is a string. This dot first name. This guy's a string. And this guy's a string.
It's displaying that
Yep.
one.
So I'm just taking this string, I'm gluing it together with this string, putting a space in between, and putting it out. That's what the display method does. So what am I doing inside of main? I'm building a brand new my object, calling the constructor that takes the first name, and look when I highlight over this. Just gonna do it. There we go. Takes the first name, takes the last name. Now we know exactly how to call this guy. Does that make sense? Because of the way we wrote the method. So I'll pass it a first name, I'll pass it a last name, then I'll tell that guy to display himself, and we'll see Mike Littman gets printed out. Similar, I can create a second my object, mo2. This is going to be a my object, passing it Donald Duck, right? You thought I was going to do Donald Driver, didn't you? Yeah. Only one Donald in my book. All right, so we'll do mo1 is Mike Littman, mo2 is Donald Duck. I'll tell mo1 to display itself, I'll tell mo2 to display itself. So it should just show Mike Littman, then it should show Donald Duck. I'm calling the exact same display method, but one of them knows how to print out Mike Littman, the other one knows how to print out Donald Duck. Does that make sense? Now notice something. about this display method. Class method or instance method? How do you know? No static. It's an instance method, no static. We finally wrote one. Notice how we're calling it. How do we call instance methods? We call them using an instance of the class in which they were defined. This is an instance method because I'm calling it with an instance of my object. I'm calling this guy with another instance of my object. So MO1 is calling his version of the instance method display. MO2 is calling his version of the instance method display. And MO1's version of the instance method display knows that this dot first name is Mike and that this dot last name is Lippman. But MO2 knows that his first name is Donald and his last name is Duck. Start making sense? How the instance methods work, why we have instance methods? We want every single instance of my object to have its own version of this crap so they can display themselves. Make sense? Now, right now we have a fairly weak object from a couple of perspectives. One of them is this. I'll print out my two names. And now I'm going to say MO1 first name is equal to Barry. And then I'll say MO1 dot display. I externally modified my object. How would you feel if somebody came along and just changed your first name and you were the last one to find out about it? So that's where we need to talk about our security flags. Field/method security. We have public, we have private, and we have protected. If we put nothing there, the default is something that's called package level. In C++, this was called friend level. But it's not something we can actually define in Java. It's like if you don't put any security level in front of it, this is what it is. So right now, all of ours have nothing in front of it. Here's our two fields. We have a first name and a last name field. We didn't put public, private, or protected in front of either of them. We have our constructor. Constructors are almost always made public. You probably actually saw me slip one in earlier, but I deleted it in preparation for this discussion. So I put nothing in front of this guy, and I have nothing in front of this guy. So by default, all these guys are package level security, whatever that means. Okay?
Public in the same package.
You can access it anywhere in the same package. Where the package is this guy, the default package in this case. So as long as you're some guy underneath this subfolder, you can access all these guys. Okay? Never make it default. Never use the default. Bad news. Okay, that's your first rule of thumb. Public means everyone can access this. Access it. Private means only accessible within the class, the field, or method was defined in which whatever, define them. Dangling preposition, bad grammar, deal. Okay, so private means you can only access it if you are inside the class that it was in which it was defined. Protected is like private, but you can also access it from within children of the class. We're going to learn about something called inheritance in here. We're not going to talk about it today, but we will talk about it. The general gist of that is we are all human beings, right? Okay. So at the top of the tree, there's a human object. We are all humans, but we are special versions. Some of us are male, some of us are female. So male humans are humans, female humans are humans. But we're both subclasses of human. Does that make sense? So all humans, whether you're male or female, you have eyes. So maybe eyes is set up as protected because we all have access to our eyes. Male and female. We got it from our parents. All humans have eyes. But males have certain things and females have certain other things. And, that's where things start deviating. And, I'd probably send you down like the nursing department or something like that to clarify some of those differences, I guess. It's like, look, we were in grad school. It's like, if this is still a wishy-washy subject for you. All right, so in any case, that's what protected is. But what we're most interested in here right now is public versus private. What I think you should always do is make everything private initially. Literally everything. All right.
Wait, so what about the public class, my object?
Yeah, you can make that private too if you want. We're gonna remove these things real quick.
Oh.
So yeah, we could make that private if you want right now. It would never make sense to make a class private, okay. But we can make it private. So now, what we want to do after we make everything private initially, we want to loosen the reins as much as we need to loosen them to have access to it. Well, we definitely want to have access to the myObject class over here inside of hello, which means that I can't make the class itself private. And for us right now, our options are public or private. Either everybody can see it or only we can see it. That's how we're going to solve problems right now, because we're not talking about protected yet. So we're going to make this guy public again. Now, first name and last name, we only need to access those guys inside of this class. So we're going to leave those guys as private. Now, I do want to be able to build my objects outside of this class. I need to be able to call upon that constructor, this guy right here. I need to be able to call him inside hello. Therefore, I can't make my constructor private. I need to make him public. Similarly, I want to be able to call my display method from someplace else. So I also need to make him public. So I have a public constructor, I have a public instance method, but I have two private fields. So these fields are only accessible somewhere inside of the myObject class, which means if we come outside and hello, notice it's screaming at us now when I hijack the dude's first name. It says, you don't have direct access to that guy. That make sense? Okay, so that's the purpose of putting security settings. A lot of people just avoid any security settings. I think that's a mistake. Don't think about it as protecting your data. Because very often we're going to be writing things that it's more just we're just creating a quick little algorithm for solving something. We're not dealing with secure data. We're not dealing with something that's a big deal, blah, blah, blah. So don't think of it like that. That's not the reason why you use the correct security measures. The reason we use it is to minimize errors. We control the way our code gets called. Does that make sense? If we leave it completely open, now we've made our objects significantly easier to abuse. Let's say we rely on the first name being all lowercase. And in the constructor, let's say we test it. Whatever you pass in, we make sure it's lowercase, or we just convert it to lowercase. But then we leave our first name unlocked, let's say, make it public. Somebody else can go in and directly replace our all lowercase first name with any name they want, with uppercase letters in it, which might then break other parts of our program. Does that make sense? So it's reasons like that, where if we lock it down, we can control the way people should be using our programs, should be using our objects. All right. So now, let's say that I actually want to change the name of this this person. So I'm inside of hello, and I do in fact want to change Mo1's first name to Barry. I can't directly access their first name anymore, right? So in order for me to change that, I'm going to have to create a method. In the modern world, object-oriented world, we call these methods setters. It's just the naming convention. It's a method, normal method, nothing special about it, but they're called setters. Historically, they were called mutators. They allow us to change something. Okay? So I'll put these both on the same slide. So setters and getters. Or mutators and accessors. Mutators let us change a private value. Accessors let us access a private value. Setters let us set the value for a private field. Getters allow us to get the value for a private field. That make sense? So we'll come into my object. And if we want to be able to set the first name, we'll go ahead and create a public method that returns nothing called set first name. This guy will take in a first name as a parameter, and we'll say this dot first name is equal to first name, for example. Make sense? So now inside hello, I can say mo1 dot set first name to Barry, and then I can say mo1 dot display. And I'll see that my name's been changed. Similarly, I can create a public string get first name that takes no parameters, and I can return this dot first name. Now, I did not actually need to say this dot here, because variables, again, resolve to their most local definition. So when I said first name right here, the most local definition of first name is, in fact, the first name that was defined way up here. That make sense? I still recommend that you say this dot. I think it's more expressive. It'll never be wrong. And it's convenient because you can just type in this period and then it'll spell out first name for you. So there's all sorts of advantages, even though the end result is a little bit more code. That make sense? Okay. So this allows us to get access to first name. This allows us to set the first name to something. So if I only want to allow somebody to directly access the first name, maybe I don't give them that method. Now I've made first name read only. That make sense? So setters and getters allow us to have read and write control over private variables. So that's why I say make the variables private. Make everything as private as you can make them. And then give yourself the access that you need as you need it. That make sense? Now, something cool you can do with Eclipse, let me get rid of these setters and getters here, is you can right-click in here. So we have two private fields. I can right-click, go to Source, and go to Generate Getters and Setters. So here's all the stuff here. I can just put check marks next to both of them I want, or I can specifically say I want to be able to get my first name, and I want to be able to get and set my last name, let's say. Okay, so this will create two setters, or I'm sorry, one setter and two getters. Hit OK, and it goes ahead and builds them for me. There's my methods. Puts the curly braces in places I don't like, but Small price to pay. Especially when you have classes that have a bunch of fields, not just two. That make sense? Okay, so those are objects in a nutshell. So what we can do is we hid all the details inside of here, so we can just use it externally. So for our example today, I want to keep talking about string parsing, kind of the same thing we were talking about last time and the time before. How many of you have ever heard of something called JSON? 1 1/4 people? Yeah, what is JSON? Or you just heard of it?
I heard of it, but I believe it's from the web programming languages.
Okay.
Can't remember exactly what JavaScript.
How many of you have heard of XML? Okay, more people have heard of XML. What is XML? Okay, Extensible Markup Language is what it stands for. What is it? That's kind of like what she said with the JSON.
This one is for transmit those information from the server and from the Excel.
It's true. How come you didn't raise your hand?
At least he's honest.
XML is a language. Remember when we talked about there are different kinds of languages, and I said there's domain-specific and there's general-purpose languages? XML is a domain-specific language. It's a language for defining other languages. For example, you can define HTML using XML. And you've maybe even seen this before when you had an extension of .xhtml. .xhtml is XML certified HTML. HTML has become fairly bastardized. That's why we now have a whole industry that deals with making web pages look the same across the 3 or 4 major browsers. Really the 3 major browsers, right? Internet Explorer, Firefox, and Chrome. You throw Safari in there, but really Safari and Chrome are pretty much the same. They're both built on WebKit. But you get the point. You know, you need to make sure a web page looks the same across all 3 of them, or all 4 of them, whatever. Why? Well, because way back when HTML first came out, HTML came out before XML. And the early web browsers, well, what's a web browser? Like Internet Explorer, all those guys, what are they? All they do is they take HTML and translate it into pretty pictures and text. Right? That's what they do. Well, in the early web browsers, they accepted a very loosely defined version of HTML. So you didn't have to write correct HTML in order for the web browser to display it. It would sometimes do best guess type stuff. So now what we're left with today is we're left with all these newer web browsers that still have legacy code in them, so they still work for old web pages. To the point that now brand new web pages don't necessarily always look the same because of case-specific problems that were solved 10 years ago. Kind of get what I'm saying? So when a web page is a .xhtml page, the web browser knows that it can parse it using the 100% XML standard of HTML, not the hodgepodge HTML leftover from day one of internet engine that's inside of it. Okay, but the important thing for this discussion is XML is a language for building other languages. Specifically, it was invented for places on the internet to exchange information with each other. So, for example, let's say we wanted to have my object text. I might have a my object. And a my object has a first name, Mike, and a last name. Can I left justify this from in here? Format? Okay. So that's an example of what some XML code might look like. And then I could create a second my object block here for Donald Duck. That make sense? So then what I could say is I can then build, if I'm transferring over the internet, transmitting over the internet, I can build a my object out of its XML equivalent. That make sense? So I can go ahead and add a second constructor. I can say, well, let me come out here to our hello first. Get rid of these guys. Okay, so here is a string, except let's not do it for Mike Lippman. Let's do it for David Letterman. Oh, that's a good one. David Letterman. So David Letterman is going to be a my object, and here's the XML representation of David Letterman as a my object. Okay? So we want to have a second version of our constructor, a constructor that can take in an XML string for a my object rather than a first name and a last name, but still build the my object. Okay? So we're going to create another constructor. It's also going to be public. It's also going to be called my object. Okay, because all constructors in Java have the same name as the class. This guy's going to take in a single parameter called XML string. And what we need to do is we need to parse a string that looks like this and pull out the first name and pull out the last name. That make sense? Okay, well, how do I do that? How do I take something, and we'll drag this code in here for our little example. So our input might look like this. That's an example of what our input could look like. How would we get the first name and the last name out of there? Okay, we can use the tokenizer. Okay, what are we going to tokenize on? What if we tokenized on less thans and greater thans? Well, so let's start with that. So we're going to create a string tokenizer. And we're going to pass it our XML string, as well as a string of delimiters. And we'll just do less than, greater than for right now. And it wants us to import the thing for tokenizer, java.util. And just for right now, why don't we go through and say while st.has more tokens, let's do a system.out.println st.next token. Just spit all the tokens out one at a time. Okay? Just to see what this guy does for us. So it's not actually fully constructing this thing yet, so don't try to call display methods and stuff, but we can at least test it. So we'll go ahead and we'll create a myObject mo3, and it's going to be a new myObject, and we'll pass it our XML string. All right, and we should see a bunch of tokens displayed on the screen, and we can see if any of them seem like they'll be helpful. So we have myObject with the first name, David, / first name, last name, Letterman, / last name, / myObject. Well, we definitely have our first name right here, and we definitely have our last name right here. Correct? How can I pull those guys out of there? Well, if we're guaranteed that a myObject XML string looks like this, if we're guaranteed that, then we know that we can just pull out which values. We can pull out, this is token 0, 1, we can pull out token 2, and 5. That's our first name and last name. Correct? So burn through token 0, burn through token 1, grab token 2. Because remember, the tokenizer, once we use a token, it's gone. So we can say st.next token, burn through 1, or burn through 0, burn through 1, set this dot first name equal to 2. Burn through 3, burn through 4, this dot last name is that. Does that make sense? So now I should be able to say mo3.display. And there's my David Letterman. That make sense? Now, what would happen if I put some spaces and things like that in here? So we do have a space there. How can I get rid of spaces around the name? I can use the trim method. So what I can always do then is inside myObject, I can trim those two tokens before I put it into my, that'll take the white space out on either side. Why did that happen? Oh? Trim didn't break it. It was broken before trim. Okay. The spaces as tokens.
Yeah, we had the issue last
Oh. I get what you're saying. It did this. I think we had like a space here.
Mm-hmm.
So it took this space as a token and then also took this.
Right.
Okay. Well, how do we fix that? Oh, you want to put the spaces in as a token? Okay. Throw a space in there. Yeah, so now, well, now we have problems because now we have spaces in between these guys.
So erase the spaces in between those, and then you'll be all done.
Well, in order to properly handle XML, we probably need to have an XML, an object for parsing XML, right? Okay, so we're going to have to write an object for parsing XML. So we'll add another object, new class, call this guy XML parser. And XML parser is going to take in a private string, XML string. We'll have a public constructor called XML parser that takes a string, XML string as a parameter. And we set this dot XML string equal to XML string. Okay? And now what we need to do is we need to build up opening tags and closing tags and values. So we're actually looking at a fairly simplified version of XML here because there's actually XML. You can have things like value equals 7 and stuff like that inside of the tags. But let's pretend that doesn't exist for our example here. Our example looks like this. So we really have 3 different things we're looking at here. We are looking at opening tags. How do we know we're looking at an opening tag? We're looking at an opening tag because we see a less than followed by something that's not a slash. That make sense? We know we're looking at a closing tag if we see a less than followed by a slash. And if we are looking at something that's not one of those, then it must be one of these. So values, actual values, follow a greater than sign and are before a less than. That make sense? But we want to write a parser. We want to capture opening tags. And we want to capture closing tags and capture values in the middle and do something with them. Okay? We can assume that our XML is properly formatted. So we can assume whoever's sending something to this is giving us properly formatted XML. That is, we are always going to see an opening tag first. Then we will either see an opening tag or we'll see a value. We know it's an opening tag if it's a less than. We know it's a value if the next thing we run into after a greater than is not a less than. That make sense? So, what we're going to do here is we're going to create a couple of arrays. We're going to have a string array called opening tags. Let's call them O tags. We'll create a string array called C tags. And we'll create a string array called vals. All right? Now, we don't know how many of those we're going to have yet, right? So what we're going to do is we're actually going to have a couple of counters. So we're going to have O tag counter, C tag counter, and val counter. And just since we have a limitation here, we're just going to give ourselves the opportunity to have a maximum of 100 tags or 100 values, just for right now. We're going to see later on, actually it's in the next course, that this is a problem with arrays. We need to know how big they are at the beginning. So now we're just going to make them big enough. It's kind of like we're making a bunch of food, so you're going to pull out the pan that you know is big enough, You don't know if you're going to be able to fill the whole pan, but you know you won't overfill it. At least you hope you don't overfill it. That's the idea. So we're going to say O tags is equal to a new string array of 100. C tags the same thing, and vals is the same thing. And then we'll also say O tag. Here's an example of where this comes in handy. This dot O tag counter is equal to 0. This dot C tag counter is equal to 0. This dot val counter is equal to 0. All right, so again, this is what constructors do. They initialize all the stuff that we need to have initialized for a object. So for this object, we need to keep track of our initial string. We need to keep track of we need to initialize our initial arrays and say we haven't found any tags. Now we need to actually go through and parse this guy. Okay? I'm going to create a second string up here called curstring. And right off the bat, I'm going to say this dot curstring is equal to this dot XML string. So we're going to have two copies of that original guy. We're going to allow ourselves to change curstring, but we're always going to keep XML string in its original form in case we want to display it or something like that. Okay? So curstring is like our changeable version of whatever was originally passed in. Now we're going to write some methods. Again, exact same pattern. We need a method for finding opening tags. So we're going to say we're going to have a private method. Let's have this guy return a string for right now. Find next O tag. And what he's going to do is he's going to find the next opening tag inside of curtag, or curstring. I called it curstring. So, in order to do that, I need to do what? I need to find the next occurrence of less than, right? An opening tag looks like this. Keeping in mind that we might have some spaces, some white space before, potentially. That make sense? Yep. Before the tag, we might have some white space. So we're going to build up the O tag. So the O tag is going to be the empty string. Actually, let's do this. Int pos is equal to 0, while curtag dot, that's not curtag, it's curstring, dot charat pos is not equal to that. Not equal to or greater than, which would be the end of our closing tag, right? While it's not equal to that guy, we want to build up tags, build up elements. Okay? And what are we going to do? We're going to say the O tag plus equals curstring dot charat pos. Finally, this is going to end, and we will return the O tag concatenated with that final closing thing. And if we want to get rid of the extra spaces, we can just go ahead and trim that. So let's start with just this. So inside here, we're going to say system.out.println this dot find next O tag. Now our hope is if we call it, passing it a string that looks like this, we get my object printed out. We find that first opening tag. All right, so that's for our XML parser. So now we got to go back to hello, and let's forget about my objects for a little bit. Let's just deal with our XML parser. So we're going to say XML parser XMLP is equal to a new XML parser passing it our XML string. And as part of that constructor, it's going to print out the first opening tag it finds. So we don't actually have to do any other printing. We're going to print this, and hopefully it finds. Oh, hold on. We haven't actually changed pause. We need to increment pause each time through there. Otherwise, we have an infinite loop. All right, so there's our my object, our first tag. That makes sense? And we'll see that if we come into hello, and we add some spaces in front of that, that it'll take those spaces out because we trim it. That make sense? Okay. Have we looked at substring yet? Good. Okay. So now before we trim it though, we're going to say the O tag is equal to the O tag concatenated with that last character. We know that that is our the actual opening tag. But before we return that, we need to whittle down our cur string so that it no longer has that opening tag on it. That is, if cur string started off looking like this, after this guy is done, it should start with that. We want to take my object off. We already captured him. Now let's get him off of there because the next time we look for an opening tag, we want to find first name. That make sense? Okay, so I need to write a function that removes a string from the beginning of. Okay? So we're going to create another private function, private void remove string. So we'll say remove string s. Actually, let's call it remove from front. String s. Now, do we even care what string s has? Or do we just need to know how many characters are in there? We just need to know how many characters. We want to build a brand new string starting after the number of characters that are in S. So we're going to create a string new cur string. We'll start that off as the empty string. We'll say for int I is equal to s dot length. S dot length minus 1 should be the last character in the string that we want to return. We want to start from 1 past that. So we'll start at s dot length, keep going as long as I is less than cur string dot length I plus plus. And each time through, we're going to say new cur string plus equals cur string dot char at I. And at the very end, we'll say cur string is equal to new cur string.
Is you turn that out? Well, you can't.
No, because it's a global variable. It's this guy. I'm just changing him. I'm changing his state. All right, so after we print out that first tag, let's go ahead and then do a system.out.println. Well, I want to stay consistent here. This dot cur string, and I'll do the same thing down here. This dot, this dot, this dot. So we'll find that first tag, which we've seen work. So what does the find first tag do? It gets that O tag. Then we're going to say this dot remove from front the O tag. Then we'll return the trimmed version of that O tag. We don't want to trim it beforehand because we want to make sure we get all the extra characters, right? So now when we run this, inside of our constructor, we should see it print out our first opening tag and then print out a new updated version of our XML string, which should start with first name. That make sense? All right, well now we need to get another opening tag, right? Here, I'll just steal these two lines. We'll just repeat that. We got my object, we got first name, and now we're at a value. That make sense? Now, what's interesting here is, what would happen if we kept getting opening tags?
Well, we could have put it in a loop.
Okay.
We didn't have to print it out and create these. Had it only print out if there was no.
Well, we want this guy to be pretty generic, this XML parser. We want him to work generically on any kind of XML. We know what our particular XML string kind of looks like. We know that all XML strings should start off with an opening tag. But we don't necessarily know if the next thing will be an opening tag or if the next thing will be a value. We don't know the answer to that. So, what we really want to do here is inside XML parser, we want to keep doing something while cur string dot length is greater than 0. As long as we still have characters to parse, let's do some stuff, right? Let's create a string called temp. And let's go ahead and let's try to read in an opening tag. Temp is equal to this dot, what is it, read? My first, find next tag. This dot find next tag. All right, so now this guy is hopefully going to be a next tag. How does find next tag currently work? Well, it goes through and it's looking for a greater than sign. Right? Well, where's the greater than sign? The greater than sign, first time it'll find that is right here. Next time it finds that is right here. But the next time it finds it is right here.
So you have to find open, mean less than n or greater than.
In order to find an opening tag, we need to find the first occurrence of this. And then the next occurrence of this.
So the closing tag would be those two plus the forward slash.
Yep. So we need to see what comes first in our string. What comes first in this string is an opening tag. How do we know it's an opening tag? Because we're going to ignore white space, and then we're going to hit something that's not white space. And what we hit that's not white space indicates what we're looking at. If we're looking at a less than sign, then we know we're dealing with a start tag. If we're looking at something that's not a less than sign,
We go all the way up to the less than.
we're looking at a value. Okay, so we could be looking at a start tag. And if we just keep piecing these guys off, so let's say we find that tag, now he's gone. Another start tag. Now we're looking at this guy. What if we're looking at that guy? We might misconstrue him as a start tag when he's actually an end tag. There's really three different forms that we might run into. We might run into something that is purely a start tag. Okay, that is a less than sign followed by something that's not a slash. We might run into something that's an end tag, which is a less than sign followed by a slash. And if it's neither of those, then we're building up a value. Okay? So if it's a opening tag, we're going to keep collecting stuff until we hit the greater than sign. If it's a closing tag, we're going to keep collecting stuff until we hit the greater than sign. If it's a value, we're going to keep collecting stuff until we hit the less than sign.
What a less than and a forward slash.
We could say that less than and a forward slash, but we don't even need to worry about that because all values will always end with a less than forward slash. Okay? So now we need to make this get next a little bit more generic. Let's just call this get next. So get next is going to return a string. It'll either return an opening tag, a closing tag, or a value. Make sense? Okay. So first thing we need to do is we need to burn through all white space. We can do that real easily. How? We can just say curString is equal to curString dot trim. Now we're guaranteed to have our very first character in this be either a less than slash, or a value. Okay? So, if curString dot charat 0, if that guy is equivalent to less than, I must be looking at an open tag, right? So if it's a less than, I must be looking at an opening tag. Or I could be looking at a closing tag. Well, how do I ask that? Another question. If curString dot charat 1 is equivalent to a slash, I must be looking at a closing tag. Else, I must be looking at an opening tag. That make sense? Now, if I'm not looking at one of those, if I'm not looking at an opening or a closing tag, then I must be looking at a value. That make sense? That's what I must be dealing with. Okay. Let's say that I'm looking at a closing tag. I'm looking at a closing tag, that means I'm currently looking at my first two characters looking like that. So I want to keep collecting crap until I hit a greater than sign. Correct? Okay. Start pause off at 0. So while curstring dot char at pause is not equal to a closing tag, then what are we going to do? We're going to say temp plus equals curstring dot char at pause, and then pause plus plus. So we'll build up our closing tag, right? What if we're looking at an opening tag? Same exact thing. Whether I'm looking at a closing or an opening tag, it does not matter. I'm looking at something that's not a value. What do I do with it? I build it up. And once I'm done building it up, what do I do with it? I return it. Keep in mind, I still have that one last guy there. We need to do the same thing we did before. Actually, we don't even need to do it in here. We'll do it at the very end. We need to do it with whatever we're dealing with. So this guy goes through and it will build up everything. And then we have temp plus equals the greater than sign to complete it. That make sense? But don't do any trimming yet. If we're not looking at a tag, we must be looking at a value. If we're looking at a value, what do? We read crap in until what? Till we hit a less than. Looking at a value, keep reading crap in, building it up in temp until I finally hit a less than. Now, we don't want to tack that less than on here, right? That's not part of my value. So we're not going to do a little extra tack on there at the end. Now, regardless of what we just built up, we just built something up inside of temp. Okay? Whether it's a tag, whether it's an opening tag, a closing tag, or a value. We built something up inside of temp. So I need to say this dot, remove from front, temp. Let's cut that off the string, then return temp dot trim. That make sense? Okay. Let's go ahead and let's have it read all the tokens. So we're going to say get next, read it into temp, the string I created right here, print it out. Keep doing that over and over and over again. So we need to do it at least once. We need to get the ball rolling. Keep doing it over and over and over again until temp finally boils down to something that's nothing, the empty string. That is, we didn't build anything up. That make sense? We'll deal with the index out of bounds here at the end. We got a my object. We got a first name. We got a David. We got a first name. We got a last name. We got a letterman. We got a last name. We got a my object. Things seem pretty legit, right? Okay. One little issue here at the end. XML parser, line 47. We tried to access char 0 of the empty string. Don't do that. Don't try to access char 0 of the empty string. Well, we can just say this. If per string dot length is equal to 0, return the empty string. Get us out of there. Because what ended up happening is we had an extra white space that wasn't trimmed beforehand, but then we trimmed it right here. That make sense? So I have all of my little tokens. Opening tag, closing tag, or value. How do you know? No forward slash. It's a less than, but no forward slash. Opening tag, value, closing tag, opening tag, value, closing tag, closing tag. Could we write little functions to determine which kind of guy these are? Yeah. So why don't we do this? Why don't we say private void add token. This guy I'll take as a string as a parameter. And depending on what kind of token it is, we'll add it to either O tags, C tags, or vals. Make sense? So, if s dot char at 0 is equivalent to less than, then I know it's a tag. If s dot char at 1 is equivalent to a slash, then I know it's actually a closing tag, right? And if it's a closing tag, what am I going to do? I'm going to say this dot C tags at bucket what? This dot C tag counter is equal to S. Then I'll say this dot C tag counter plus plus. We just added a closing tag. Otherwise, this must be an opening tag. It's an opening tag. And I'll say this dot O tags at O tag counter is equal to S and O tag counter plus plus. Otherwise, it must be a value. And if it's a value, I'll say, well, I'll just write the whole thing again just for this one. These vals are a little different. This dot vals at bucket, this dot val counter is equal to S. This dot val counter plus plus. So calling add token will drop it into the correct bucket. So So rather than printing out temp, what do I actually want to do? If temp.length, actually I think we should be okay. We're going to say this dot add token temp. That should put it into the correct buckets. Finally, let's write a little function. Private void show tokens. That takes no parameters and goes through and shows all of our opening tags, all of our values, and all of our closing tags independently. So system.out.println open tags. Orient I is equal to 0. I is less than this dot O tag counter. I plus plus. System.out.println this dot O tags at bucket I. That's what we'll do for the opening tags. Then closing tags. C tag counter. C tags. And finally, vals. Val counter. And vals. So we'll have this guy go through. After we've collected all the tokens, we'll say this dot show tokens. So what did we do? We parsed it. We collected all these guys into our arrays, into the correct arrays, and then we'll prove it by printing out all the opening tags, all the closing tags, and all the values. Oh, there you go. Hello. That is right here. Need to make sure we don't try to place something that has no values in it. So there's our opening tags, there's our closing tags, and there's our two values. That make sense? Okay, so we were able to write a parser that goes through and gets all the individual pieces, does something with them, and we could probably take this the next step and actually use those pieces to create our language, right? Well, how do I know which value went with which tag? Say this again? Well, so if we look at our output there, let's run it again real quick. I read in my object, and the first value is David. How do I know that my object is not related to David? I need to know who belongs to who. Well, I have David right here. Which opening tag is David associated with? We know its first name. But how can we tell from the program that it's first name? Well, here's David. We have 2 values, yet we have 3 opening tags, 3 closing tags.
The first one is the first one.
How do you know? Why isn't it my object?
That's the first name doesn't start with the person. Like the first name under open space.
It's just the first 2 tags. And
No, we got to be able to do this generically, though. We have human knowledge of what our string looks like.
It starts whenever method.
If there is no, if there's a greater than and then a less than sign together, then you know you're still on time. But until
There's
you
a
just
greater
have-
sign. Well, no, hold on. This is what we have. We've collected all our tags. We have 3 different arrays represented here, right?
Right.
We have an array that has 3 elements in it for opening tags. We have an array that has 3 elements in it for closing tags. And we have an array that has 2 elements in it for values.
In the method, when you say show the tag, that is like print out, so you go to the row. It will be the first one which will be the tag. That's the method also keeping on the if you put back to the method.
Well, let me ask you this. If we run into a value, did we definitely just read a value that's associated with an opening tag? What I mean by that is if we're here in add token and we're inside this else, well, we're actually adding in a value,
Yes, it's a tag.
do I know that the previous thing I added must have been an opening tag?
No.
Well, think about this.
No.
Hold on. The answer is yes. Yeah, so I want you to see it. If I just read in David, and I'm adding that to my list of values, do I then know that the previous guy I read in must have been an opening tag? In fact, it is the opening tag associated with David? Do I know where I can find this guy?
Yeah.
He's in my O tags array.
Yeah.
At what bucket? O tag counter -1. That make sense? So what I could actually do, just to kind of prove this real quick, when I add something to my when I add it here, rather than just adding in the value inside of the vowels, what I'm going to actually add is I'm going to add this dot O tags at bucket this dot O tag counter -1 concatenated with, let's do a colon, concatenated with S. So what I should get then is first name, David, last name, Letterman, for my values. So I'm associating them with the opening tags that they're connected to. First name, David. Last name, Letterman. Does that make sense? So I'm defining whose value those are. And if I really want, I can strip away those tags. So now what I can do is I can write something like this from my parser. After I do all the parsing, all this crap, I can say public get value for key string key and I want this guy to return a string. So I equals 0, I is less than this dot val counter, so all my vowels, I plus plus, and for each one of my vowels, I want to look at my 2 tokens. How do I look at tokens? I use a tokenizer, right? I can split on the colon. So I'll create my string tokenizer up here. Inside here, He wants me to import java.util. So inside here, I'll say if st dot next token dot equals key. If those guys are equal to each other, then I want to return st dot next token. So inside here, we're going to say st is equal to a new string tokenizer. And what are we tokenizing? We're tokenizing this dot vals at bucket I on the string colon. If we're still alive right here, we're going to return null. We don't actually have a value to give you. And then to test this, what we can do here at the very end is we can do this. Inside of XML parser, let's so this is where we do all the parsing. Let's not show the token so we won't have any output here. But what I'm going to do is out here in our driver, we built our parser. Now I'm going to say system.out.println xmlp.get value for key. The key is going to be first name. As a string. And we should get David. Similarly, we can say, give me the token for the last name. And it'll give me Letterman. That make sense? So now, now using our parser, we can come into a my object, and when we take in an XML string, I can get rid of all this crap. And inside here, instead, what I can do is I can say I want to create a brand new XML parser. Passing him the XML string that came in. Then I'm going to say this dot first name is equal to this guy, and this dot last name is equal to this guy. So get rid of all that, and now we can say my object, mo, is equal to a new my object passing our XML string in as a parameter. Then we'll say mo.display. So we're calling the version of my object's constructor that takes in an XML string. And this guy builds an instance of our XML parser and extracts the first name and the last name, setting our two fields. And in the end, this should print out David Letterman. Now, that was a lot of crap, right? A lot of code we just wrote. I wouldn't expect anybody in here to just write that. But here's the important part of this. Look at what main looks like. It's nothing. That's the point of object-oriented programming. Remember when we were in the first day of class, I think, when I was talking about, I would usually point over here, the object-oriented version of a telephone versus the procedural version of a telephone. Procedural, we see the giant pile of wires and all this stuff laying on the table, right? We've been dealing in the procedural world here, which is method after method after method, right? All out here in the open where we can see it. But now we're in the object world. We definitely don't want to look at this parser too much. I mean, all hard programs are made up of a bunch of easy parts. None of these individual parts were difficult. But this was a relatively complex problem we just solved, right? I purposely picked a relatively complex problem to drive home this point. We've now written this and it works. Now we don't have to worry about it. What do? Well, if I need to parse XML stuff, I just build myself an XML parser, then ask for the couple of pieces of information I need. And all the magical stuff is underneath the hood, and we never have to look at it again because we know it works. Does that make sense? Just like that telephone, the object-oriented version of the telephone, we know that some engineers spent a lot of time designing that phone, had all the little wires in there with soldering irons, all that stuff. We know if we open that up, we wouldn't understand it. So we don't. We just use the phone, right? We're all running around with smartphones. We don't know how the inside of them works. We just love the fact that they do. And we use it. Kind of make sense? This is the beauty of object-oriented programming, what we just did here. We took something complex, fought through it, wrote it once. Now, I don't think we've done extreme testing on this. There's probably some things that would break it or something, but let's just say it works. We wrote it once, and now we can use it for a general set of problems and never have to really go in and tweak the details again. Make sense? Okay. Let's quickly look at your homework assignment.
You need the fan to see.
Yeah, of course.
Thanksgiving, Black Friday.
You're going to count a shopping holidays? Well, you got Thanksgiving, you got Black Friday.
And then Cyber Monday, Small Business Saturday. I mean, if you really want to go there, we can give a whole list. Every day.
We're out on a holiday.
You should probably be just thankful that I'm giving you an assignment that's only dealing with writing the object-oriented version of fractions rather than parsing something. Could be worse, I would think. I could have just given you what we just did as an assignment.
We, no. My brain already is.
Wasn't that fun?
It was.
It was.
But I'm also psyched.
It was exhilarating. That still Unit 3? Homework 6? Okay, so create a fraction class that has two private fields, numerator and denominator, of type big integer. A fraction should be able to display itself. It should also be able to add itself to another fraction, returning a new fraction in reduced form. It should also be able to subtract another fraction from itself, returning a new fraction in reduced form. Make sense? So what did we do today? We used big integers. We did all the fraction stuff minus subtraction, which is same thing. Just get a common denominator, you're good to go. Right? So now I'm asking you to take all that crap, pack it into a class called fraction, and do all the stuff with fractions instead of with instead of arrays of two elements. That make sense? Okay. So that's that question. And then report number 6. 3 to 5 page paper discussing the role of computer programming in the IT industry. So for all of you who keep asking me, well, am I really going to need this in IT? The answer is yes. It is widely believed that computer science is programming and IT is not. This couldn't be further from the truth. Programming is to a computer scientist and an IT professional as the hammer is to a carpenter. It is a tool we use to solve problems. Computer science is 75% creation and 25% application of created technology. IT is 25% creation and 75% application of created technology. So they're opposite sides of the same coin, and both sides have programming on them. What types of problems might an IT professional solving? It sounds like some of the crap you guys write. Using computer programming as a tool.
So what is it really?
What type of problems might an IT professional be solving using computer? Yeah, what could IT professionals solve using computer programming as a tool?
Obviously, we learn from the best.
Seriously.
Right.
When is it preferable to create a custom software solution rather than a pre-made solution? Make sense?
Didn't we already answer that second question?
Well, not really. You answered a question of when is it better to create a easy to read solution versus a
No,
well,
no,
you've answered it two different ways.
No.
Two assignments ago was when it was like, using Excel or something like that. Now we're actually talking about it in programming terms, I guess is what I'm saying.
Oh, okay.
When do you use a programming package, a library that's already been created, like an XML parser,
Gotcha.
versus writing your own?
Okay.
Make sense?
Now it does.
Okay. So, questions about any of that?
Can you say, like, what he did with the Amazon stuff and just
Well, he erased most of it, remember?
I did erase most of it, didn't I?
Yeah, you did.
the
Don't worry, I'm gonna go through them videos like
Let me see it.
extensively.
I'll be doing videos.
You want me to upload you?
Yeah, if you wouldn't mind.
YouTube?
I don't care.
That's part of it. Yeah.
What's that? Who?
I know just you did in the class object-oriented one, so just the upload and
So what do you want me to do again?
I know just upload on the engineers
Oh, this guy?
one. Yeah.
He erased most of it.
But it's still
Yeah,
there,
but still
like,
like.
that part about, like, some comments.
Can I just copy all this crap in?
Yeah, perfect.
That's good.
Yeah. Thanks, man. You're welcome.
Don't forget to take a look at that one.
Let's see. Class code from 1127. Parser. Man, look at that XML parser. Slick, huh?
I can point to where you lost.
That's that. Thing I can point to is away towards my house, away towards
We
my
can
bed.
we can do that program. Just using the object which you use in the class, without using the array.
Without using the array or with using the array?
So pretty much-
Without using the array.
Correct.
Yeah, just we have to create the object, the fraction.
You create a fraction object that takes in two parameters, numerator and denominator, and do the math. I mean, internally, if you want to store it as two bucket arrays, you can, but you don't need to. It'll be harder to do it that way.
Yeah, like can we use array?
You can if you want, as long as I see your solution as an object.
Okay.
Just like this parser thing. I don't care what's inside the object.
Okay. So
I care about what, as long as I'm manipulating as an object, I don't care how that telephone's built.
Yeah.
A phone's a phone.
Yeah, just
If
you
it's
want to see
if it's
the-
written crappily underneath the hood, that's fine as long as it still works. That makes
Yeah,
sense?
yeah.
But I want to see the object interface for it. How you actually write your object behind the scenes doesn't matter.
Hello.
Save. Let's save. Did it save? Maybe?
I'm so ready to go. Oh, I'm go to sleep. See, this is how you know I should not be driving for 30 minutes. Yeah, still golden. Alright, you have a lovely, lovely Thanksgiving. I think I'm about to beat your record on the food eating. I do it all.
I don't know if anybody could beat his record.
That's true.
I have a son who's 6'6" and weighs 450. Or now, actually, he lost 30 pounds. I don't think he could beat his record.
He could beat me
Tried,
now.
though. He tried. He could beat you now?
I had surgery and stuff.
Oh, did you?
Yeah.
Do you have to